Today we're looking at features of a quadratic that is in vertex form. We're going to go through the first two examples here together. So if you have a quadratic that's in vertex form, remember that the vertex would be the thing that's easiest to identify. So generally vertex form is written as y equals a times x minus h squared plus k. So you can see by looking at the form here that if the vertex is at hk, and it is, then we would need to use 5 and negative 4. So the vertex is at 5, negative 4. The maximum value would be y equals negative 4, and the axis of symmetry is x equals 5. So I can plot that now. So there's the vertex, and then remember the axis of symmetry is just this imaginary line, which you don't always have to plot, but sometimes it can be helpful. And I can see by looking at the original here that this parabola is going to open up, and so that max or min value is really a min. Next, I'm going to find the y-intercept, because we know that we have a y-intercept whenever x is equal to 0, so it'll be y equals 0 minus 5 squared minus 4. So that would be negative 5 squared minus 4. And that will simplify all the way down to 21. So the y-intercept is at 0, 21. Now that doesn't fit on the graph, so I'm just going to hold off on putting anything there yet for that, and we'll just grab the zeros next. So to find the zeros, you cannot use the quadratic formula or factor unless you have an equation that is in standard form. So remember, standard form is y equals ax squared plus bx plus c. So there are no parentheses. So we're going to have to take x minus 5 squared minus 4 and multiply this out. So x minus 5 quantity squared is the same thing as multiplying it by itself. So then here, if I multiply using double distribute or the FOIL method, I'll get x squared minus 5x plus 25 minus 4. Combine like terms, and we'll end up with x squared minus 10x plus 21. So then to find the zeros, I can go to the quadratic formula, or I can factor. This potentially is factorable, so I'm going to go ahead and check that first. So if I were to factor this, I would need two numbers that multiply to 21 and added to negative 10. And those two numbers would be negative 7 and negative 3. And so the zeros are at 7 and 3. So I'm going to go ahead and connect these. Now I know for the y-intercept, it's not on the graph as it's pictured, but 21 would be somewhere way up here. And so we'll just stick with this as our 3 points. Now for number 2, we'll run through the same steps. So the vertex is what I can see easily here, and that's at 2, negative 8. And then we have our max or min value, which would be at negative 8 with the axis of symmetry at 2. So there I've plotted it, and I know ahead of time that this is going to open up, and so once again we have a minimum. The y-intercept we find by letting x equal 0. And so then that gives me 1/2 times negative 2 squared minus 8. Simplifies down to negative 6. So the y-intercept will be at 0, negative 6. And now for the zeros. So just like before, we're going to have to multiply this out. So I'm going to go ahead and begin by writing out that x minus 2 2 times. And I'm going to multiply those together before I distribute the 1/2. So there's the FOIL method, or double distribute. I'm going to go ahead and combine like terms, and then I will distribute the 1/2. Okay, so there it is, multiplied out. You'll notice here at the end, 2 minus 8 does need to be simplified. And so in standard form, we would have y equals 1/2 x squared minus 2x minus 6. So from here, to find the zeros, I either need to say that I'm going to use the quadratic formula, or potentially factor. Now in this form, that 1/2 is not very nice, and so that would kind of tell me I can't ask myself that shortcut question of what are two numbers that multiply to -6 and add to -2. I would have to use like the guess and check method or take out a GCF. So I'm going to go ahead and do the quadratic formula here first. And so in the quadratic formula, we would have x equals the opposite of -2 plus or minus the square root of -2 squared minus 4 times 1/2 times -6 all over 2 times 1/2. So the 1/2 isn't very nice in the quadratic formula either, but all these numbers are even, and so it doesn't really make it any more difficult than it, typically would be. So simplifying here, we get 2 plus or minus the square root of 4 plus 12 all over 1. So 2 plus or minus the square root of 16 all over 1, which I'm not going to write. And so then my two answers, one of them is 2 plus 4, and then the other one's going to be 2 minus 4. So we end up with 6 and -2. So I'm going to write those down, and then I'll finish up the parabola. And then I do want to talk about factoring here briefly, just because that 1/2 is a little bit misleading. So remember that when we factor, you guys, we really would prefer that a value be a 1. And I can take that 1/2 out of every term because it's a GCF. And then that would let me factor using the traditional method of asking yourself that question. When I take out that 1/2, you have to remember that you are actually dividing everything by a 1/2. So, it's easy on the first term. 1/2 divided by 1/2 just leaves you with x squared. But then you're going to have -2 divided by a 1/2. So not 1/2 of -2, but -2 divided by a 1/2, which makes it bigger. So that'll be minus 4x, and then it would end up being minus 12. So now when I factor, I can ask myself that question, what are two numbers that multiply to -12 and add to -4? And those two numbers are -6 and +2. And the same answers show up again. So you wouldn't have to do it both ways. You just want to go towards whatever method you can do, I would say the quickest and maybe the most intuitively. So there we go. The rest is for you to finish for homework. And remember, both those worksheets are due tomorrow.